Hello everyone, I am Marwan Abdelatti. I'm gonna present our work about tuning a GPU accelerated GA for the vehicle routing problem or VRP. So, a VRP or a capacitated VRP to be more specific seeks the optimal set of routes for a fleet of trucks with uniform capacities to deliver items to a set of customers, such that total demands cannot exceed truck capacity and only one visit per customer. Our work motivation is that GAs have efficient performance for CVRPs. They operate on a pool of potential solutions, which increases the likelihood of getting a high-quality solution in feasible time. And there are currently accelerated GA versions running entirely on GPUs, but they require many tuning parameters, where incorrect settings can result in poor solutions. So, in this work, we designed a GA running entirely on an NVIDIA RTX 3090 GPU with 10,496 cores and 24 gigabytes of memory. The algorithm has a clone restricting procedure and a 2-opt local search to further improve solution quality. In the figure below, the CPU reads the problem data file and uploads it to the GPU, which distributes it over its blocks and threads. Different kernels utilize this data to execute their functions like cost table calculation, crossover mutation, and fitness calculations. Once reaching a stoppage criteria like reaching a specific number of generations or reaching a competitive solution for demonstration purposes, the best candidate is returned back to the CPU for output. We ran a 2-to-k factorial design of experiment or DOE to tune different GA parameters. These parameters and their comparative values are collected from various studies and are shown in the top table. Pilot runs are performed on 70-node problem, and the tuning set is applied to problems of larger size. The highlighted values in the table represent the DOE outcome. The non-highlighted parameter, which is the elitism rate, has no significant effect on the GA performance. The obtained values are applied to multiple problems ranging from 70 to 400 nodes. The tuned GA shows better performance compared to arbitrarily tuning. The table below shows part of these results in terms of speed and solution quality of the tuned GA on different hardware, namely CPU, GPU NVIDIA 2080 Ti, and GPU NVIDIA 3090. It can be seen from the table that the 3090 GPU has better performance in both percentage gap and execution speed, while the CPU spends 20 minutes per loop for the 200 node problem. The 3090 GPU takes only 0.9 seconds. This reduces the solution time from 2.4 years to 12 hours for similar solution quality. Now, I'll be showing a running example of the GA solving a 23-node problem. We simply provide the problem name, the maximum number of generations, the best known solution, which is optional here, and the tuning parameter. Then the program shows the results of each generation until reaching a stoppage criteria. For more details, please take a look at our publication in the QR code below, and you can also clone our functioning code from our GitHub repository at the available QR code. Thank you, and I'll be happy to take your questions.